And a simple example problem here with charges at different corners of a square. This one's really pretty nice because it's a good way to start. But the idea is to determine the magnitude and direction of the initial acceleration of positive little q if it has mass m. Well, this positive capital Q and this positive lowercase q are going to repel each other. And so on lowercase q here, there's going to be a force of repulsion that way. And this positive q is going to repel this positive lowercase q. And so there'll be another. These will be electrostatic forces. And they're going to have, it's going to be electrostatic force is K, Q, Q, right? K, Q1 multiplied by K, Q2 divided by R squared. And here's going to be the same thing. It's going to be K, Q, Q divided by R squared. They're the same magnitude. The fact that these things are at right angles to each other makes all the difference in the world. That's supposed to be a horizontal line, but we have to go like a horizontal line. That force plus this force, when you add vectors tip to tail, going to yield the net force. Forgive my, I don't quite end up the right spot. Let's try that again. Net, just again, the net force, right about there, that's closest. Okay, that will be the F net, but it's going to be, we're going to use Pythagorean, right? A, B, Pythagorean squared, so basically we're going to go A squared plus B squared equals F net squared, C squared, I'm going to call it, but this is going to be K, Q, Q over R squared plus K, Q, Q over R squared. They're the same thing, so we're going to get 2 K, Q, Q over R squared equals F net squared. Take the square root of both sides. The square root of 2 times K, Q, Q divided by R squared equals F net. And that is the magnitude of the net force. That's F net. We're not asked about the magnitude of net force. We're asked about the acceleration. So remember, sum of the forces, or F net, equals ma. So now we know that the square root of 2 multiplied by K, Q, Q over R squared equals ma divided both sides by n. Square root of 2 multiplied by K, Q, Q over R squared n equals a. There's your real answer for the acceleration counterpoint. Now the other part is we got magnitude. We were also asked to forget about that. The direction, we add these together, right? We're going to solve for theta, that angle. Now, the fact that the exact same magnitude, you can kind of reason. Theta is going to be 45 degrees, but you could go over tan. Tan minus 1 of B divided by A, right, equals theta. And if you want to do all that math, you get the inverse tan of 1, because that's the same magnitude. So B and A are the same thing. You get over tan 1 equals theta. And you grab your calculator and do that. You come up with 45 degrees. So a second tan 1 equals 45 degrees. And that would be